Okay, so let's look at an application of intersections and unions with some actual numbers. In a survey that investigated high school backgrounds of 110 college freshmen, the following information was gathered. 25 took physics, 45 took biology, 48 took math, 10 took physics and math, 8 took biology and math, 6 took physics and biology, and 5 took all three. Okay, so let's first consider what is our universal set? How many things do we have total? Draw a big old universal set. Here we go. And, sorry, just a U. There are 110 students in the universal set. Now, not to claim there's 110 in the high school, but or in the campus, but for our information, we have 110. And I know how many subjects are there. Okay, I got an overlap of 3 subjects. I've got physics, I've got biology, and I've got math. Okay. I'm going to go with the most restrictive information. So in other words, I've got how many took math, biology, and physics, but I want to know how many took all 3. So that's going to be the centermost of my intersection. So I know that 5 of them took all 3, so there's 5 there. I know physics and biology had 6 total. So physics and biology. So this little sliver right here, that little chunk right there, had 6 of it. Well, I already know what 5 of them took, so how many more to get 6? That's the 1. Okay. I know 8 took biology and math, so biology and math, so this little sliver right here, right there, if I've already accounted for 5 of them, so that means there's 3 overlap. And do the same trick for physics and math. Physics and math had 10. So I'm looking at this little sliver here, and so if there's 5 already accounted for, that means another 5 has to give me the 10. Okay. All right, let's look at let's look math then. So there's 48 that took math. Okay, so how many do I know about already? I have 5, 10, and 13. I'm sorry, 13. So I got 13 that I already know about. So that means there's 35 that just took math. 45 took biology. So how many of that bunch do I already know about? Let's see, 6, 9. So 45 minus 9 is 36. So there's 36 that just took biology. And physics, so that's 25. Let's see, so physics, I've already accounted for 5, 5, and so I've counted for 11. And so that means 14 are just taking physics. Okay, so now we've got all these different regions, and we can go and answer some questions about this. So first question, how many students took biology, but neither took physics or math? Okay, so I can go back to my picture, and I can look at how many are in the biology bubble, but more specifically, I can look at how many, I can skip the numbers that weren't physics or math, and so how many are in the biology bubble? 36, that had nothing to do with physics or math. How many took physics, biology, or math? Ooh, there's an interesting question. We haven't actually addressed the totals. As we know, there's 110 students, but do we get all 110 in our little picture here? So let's see. If we add up our numbers, we got 14 and 30. So I'm going to add all these individual numbers up in the Venn diagram. So 14 and 36 gives me 50 plus another 5 and 5, so 61 plus another 3 gives me 64 plus another 35 is 60, so 90, 99. Is that right? Okay, so how many of them did not take, how many don't have physics, biology, or math? So if there's 110 in the total, then I want to subtract that and get 99. That means 11. Okay, let's take a look at the last question. How many did not take any of the, I'm sorry, we had 99 take physics, biology, or math. How many didn't take any of the 3? That'd be the 11. So we actually answered both questions there. Okay, for any sets A and B, the Cartesian product of A and B is written as A, well, it looks like times B, but it's actually an X. So we're not allowed to put the dot. Just A cross B is a set of all ordered pairs such that the first, I'm sorry, we don't have this fully on the screen. There we go. Such as the first component of each pair is the element of A and the second component is an element of B. Okay, so let me write this out. So A, the Cartesian product, looks like A cross B, is this such that any ordered pair, so these are parentheses, such that X is an element of set A and Y is an element of set B. And again, we say this is A cross B. It's not A times B, because that's not what we're saying. A cross B is any ordered pair where I can take every number from X and partner up with every number from Y. Okay, I want to illustrate this out as far as what that means. So let me define set A to be the letters A and B. And let me define set B to be the numbers 1 and 2. Okay, so I want to do A cross B, and I want to do B cross A, so we can see the difference between what these are suggesting. So A cross B says, let me just make a list of ordered pairs. So I have A partnered with 1 and A partnered with 2. And then I have B partnered with 1 and B partnered with 2. Okay, what does B cross A look like? B cross A would be 1 comma A, 1 comma B, 2 comma A, and 2 comma B. So all I did was switch the order of the ordered pairs. We can actually cross ourselves. We can do A cross A. And you're like, what? Can you do that? Yes, I can. Okay, so I can do, kind of write this out. So I have set A, got 2 elements, and I've got set A, it's got 2 elements. So kind of like we did up top, I've got A partnered with A, and I have A partnered with B. Okay. Now, when I go to the other side, kind of like we did, let's see, so we got B partnered with A, and I've got B partnered with B. Okay, so we can cross it with itself, and we end up with those ordered pairs.